I'm going to start by doing a general overview of all the number tools and then doing some specific examples of lessons and activities with specific tools. So first, a quick overview of all the number tile types and then dive into some examples. So we have the first category is number tiles. And so I'm going to click on any tile to put the tile on the canvas. You can click. So I just clicked on this 10 block and it showed up on the canvas. I also can click and drag it onto the canvas. So there's 100 block. I'm going to zoom in a little bit. The zoom tools are over here on the right. And then I'll put a 1 block on the canvas. I can click and drag to move it out of the way. I like a grid background here would be nice to match up with the number tiles. So in the toolbar on the right, there's a number of options for grids. I'm going to choose that grid. And I can see that the 10 by 10 block matches up nicely with the grid. I can take the 10 block, I can rotate it if I want it to be vertical, and I can move the 1 block over here. As you'll see, if you haven't worked on Polypad before, anytime that you click on a tile, at the bottom, different choices are going to come up based on the tile type. So when you click on a number tile, there's the option to split. But I also want to show you, I'm going to build first the number 30. So there's 10, I'll click to make another 10 and click to make another 10. So there's 30. And if I click and drag and I select all of those 10s, there's an option down here to merge. So I'm going to click and those 30 tiles merge together to make 1 block of 30. And when I do that, this black handle comes up. And if I click and drag that handle, Polypad takes those 30 tiles and puts them into different rectangular arrays of 30. So there's 30, there's 2 times 15, there's 3 times 10. Certainly 4 doesn't go into 30, but what I like to do with students is stop here and say, what's this picture telling us? So now I can split these tiles and I can take these 2 at the bottom and make them a different color. There's a color wheel down at the bottom to show that this is 4 times 7 plus 2. So another way to show 30 would be 4 times 7 plus 2, right? And so being able to do that with the rectangular array and move the tiles can be powerful for students to see. This block of 100, I can split it and I can click and drag to select 20. There's a delete option down here. You can also just use delete on your keyboard. I'll move the 1 over and then I'm going to merge this group of 81. And we can see again, there's a 9 by 9 and you can make all different options of the rectangular array. There's 3 times 27 down there. So all sorts of fun can be had with the number tiles. We're going to explore a bunch of those over the course of the night. But let me keep doing a quick tour of all the number types, all the number tools that we have. I'll move this over a little bit. The next one on the list is number bars or Cuisenaire rods that you might call them in school. So I can put 8 on the canvas and I can show that that's 5 and 3. You may notice these colors are not the same colors that you might be used to if you use the Cuisenaire rods in school. So on the toolbar on the right under settings, there's a few options I want to talk about here. One, I can choose alternate colors. You can see we have the British spelling of colors, which is nice. Our founder and CEO, Philip Legner, is the founder and CEO of Mathagon, and he lives in London. So you'll see different spellings. And I always smile when I see that spelling of color. But if I click that, it'll change the colors in the tile panel to the ones that match up the traditional colors of the Cuisenaire rod. So now I could do 2 and 6. The other option that I want to, the proper spelling, thank you, Mark, I didn't know that's what it's called. The other option in the settings is you can hide the number labels. And so unlike the colors where it doesn't change the colors of anything on the canvas, if you choose to hide the number labels, none of the number labels are going to show up on the Cuisenaire rods. And we'll see that happens with other number tiles as well. I want to show you that you can add a number line to the canvas. The number lines, if you used Polypad, it was in the number category, but as I said, it's now down here in tools and utensils. So I can put this on the canvas. I don't need it to be that big. And when I move it over, you can see that that doesn't match up with the 8, right? And so when you click on a number line, up in the top right are some settings for the number line. I don't want a width of 2, I want a width of 1. And so when I make it a width of 1, then I can show that that is 8 in the number bars. When let me continue with a quick tour, and then we're going to do some activities, and I'll share some things I've done in school and other teachers have shared. The prime factor circles, I just saw a note in the chat about prime climb. Yeah, that is so exciting. I've had great fun with this and great success with this with students in school this year. If you've played the game Prime Climb from Dan Finkel over at Math for Love, these prime factor circles are based on his work. This is in collaboration with Dan Finkel. We have the multiplication by heart flashcards, which I can talk about at the end if people have questions. But let me show you if you haven't seen these. So I took 18 and I put it on the canvas. I'm going to copy this. Lots of ways to copy tiles in Polypad. There's a copy option down at the bottom. What I find is the most convenient way that I copy things. If a tile is selected and I just touch C on my keyboard, it makes a copy. It doesn't need to be Command C like it does in a Google Doc or something. But if you click a tile and just touch C, it makes a copy. So there's 18. And what I think is an awesome feature here is the ability to pull these prime factors apart. So I can pull that apart to 2 and 3. And I'm showing, if you're familiar with this, the prime factorization of 18 is 2 times 3 times 3. And I can put these back together. Oh, I didn't grab both of them. I can put it back together to make 18. I want to keep it as 2 times 3 times 3 for a minute. And then I'm just going to do one more. I think I'm going to do 150. Right, so let me get 150 out here. And yeah, so I'm glad the greatest common factor LCM lessons have been great, right? So now I take this and I copy it, and I can see that 150 is made up of an orange and a green and 2 blues. And often I start talking with kids about the colors just to get them used to the idea that numbers are made up of these building blocks, the prime factors, but we have these colors. As it gets bigger, all the prime factors above 7 are this red color. So that only goes so far, but so much wonderful conversations can just be had here. Obviously, if you've worked with greatest common factor, they both share a 2 and a 3 is the biggest thing that they share. So the greatest common factor is 6, but you can use these to build the least common multiple. I like talking about all the common factors, right? We're always focused on the biggest one, but we can see, excuse me, we can see other common factors here. So I'll share some more examples tonight about the prime factor circles. But as I showed with 150, any number, I mean, I think there's a limit, but you can type any number down here and pull it out on the canvas. And as you may know, 2021 is not a prime number. It's 43 times 47. Number cards have been great. I put out on Twitter, which I will show you later tonight, an open middle question using the number cards where you can take the numbers and move them around. So you, I don't know, I'll put 6 out here, and then let me do 11. And then under settings, I currently have selected the option to merge the number tiles. If I don't have that on there and you put the 11 on top of the 6, it just stays on top of it. So that, sometimes that can be useful. I like having it as a default to merge the number tiles because unlike these, when you put them together, they multiply. When you merge the number tiles, it's the sum of those numbers, right? So if I do undo, I'm doing Command Z on my keyboard. There was the 11 and the 6, and it merges, and there's 17. I could put 30 out here and put that on top and get 47. But what's really nice here is a negative number has the effect that we wanted to. Right? If I put negative 40 out here and merge those together, there's 7. Right? So that's a nice feature with the number cards. Let me keep going, and then we'll dive into some more details. There's a multiplication grid. And so, this is a great way to think about the area model of multiplication. And so as I drag these down, right, this is now a 10 by 10 multiplication. And so as I drag it down, it's making them into groups of 100. And I can take this tab and pull it out that way as well. And so all sorts of great multiplication can be done here. This pen tool, I have a stylus and a Wacom tablet because my handwriting with my mouse is not very is not very neat. So I'm going to go to the pen tool. I'll make this black, and we could certainly see that this is 100. Right, I'm going to go to the marker. It's a little bit thicker. Here's another 100. I could count all of these by 10, right? And I could show here's another 40 and 20 and 8. We're going to do some examples later tonight of decimal multiplication with this. But what I think is great for students at the younger grades is if I take a multiplication grid, there's a pan feature over here. So I'm going to pan over on the canvas to give myself some more room. And then I'll take this and put it over here. this black dot, you can change the base in which you're multiplying. So right now you can see this is a 10 by 10 square, but if I take this dot and move it up, I can make a 5 by 5 square, right? So without even calling this multiplying in base 5, I could take this tab and move it down here and move that over there. And just, I could give this to students and say, what multiplication problem is being shown? What do I have here? 5, 10, 12 times 8 should be 96. I think I'm sure like many of you, we've had a full day of teaching, right? And this has been quite a school year. So my arithmetic skills might be failing me tonight, but is this 5, 1, 2, 3, 4, 5? Yeah, so here's a 25 and a 25, and all of these are 5s, and we could count by the 5s to get how much that is, right? And these are still 1s, and if I did that right and add those all up, I'm not going to, it should be 96. But again, I think that ability to create a multiplication grid that's not always 10 by 10 is a great way to practice number flexibility with students. And if you want to get into the formalization of multiplying in different bases, great. But even just to do a bunch of examples like that, I think is a great activity for students. There's an abacus or a reckon rec, which was new as of a couple weeks ago. So you can put that on the canvas. I'm going to move it down here. I know that these traditionally are done in red and white. So if you click on the color wheel, you could choose one of those colors. You can also use the sliders to make a custom color. So if I slide this all the way to red and turn off the green and the blue, that gets pretty close to the red and white that students might be used to. So there we go. I'm not going to get into exploding dots. If you're familiar with the Global Math Project and James Tanton's work, we have an exploding dot machine. I'm happy to talk about it at the end. He might be doing a webinar down the road with Mathagon on using exploding dots on Polypad. So stay tuned for that. And the last thing I want to show before we dive into some examples are just the fraction bars. So we can take a fraction bar, this tab, again, you can expand the fraction bar or shrink the fraction bar. I could put the 1 out here to show, 7/6 if I wanted to. What's also nice is you can split the fraction bar, right? And so I could, I split it and then I have these pieces to use individually if we wanted to do that. And then there are the fraction circles, right? So let's build one with a 9th. I'll take this, I'll copy it, and then I can put it on top and rotate it down, and I could keep doing that to build the full circle for a 9th. So we'll take a look at those tonight as well. So that was a really quick tour of just the tools in general. One of the sites I'm going to be talking about a lot, I'm putting in the chat right now, is mathagon.org/tasks. And that page came out about a month ago with all sorts of lesson plans and tutorial videos and tasks about how to use Polypad with students. So I'm going to go to that right now. I have it on this tab here, mathagon.org/tasks. If this is your first webinar with Mathagon, welcome, happy to have you. You can sort here on the left by what you're interested in. So if I unclick all of these, it'll just bring up tutorial videos. So this is a link that of the previous webinars that we did in March that were more of a general overview of Polypad at the middle school level and the elementary level. So you can go check that out if you want. And then under tutorial is how to contribute new tasks. I'm sure you're on this call. You have so many wonderful ideas about how to engage students with Polypad, how to build questions, how to share Canvas with kids, how to embed Polypads in a Google site. So again, I'm happy to stay on after and answer any questions about that, but those are all there. What I want to show you now is a new page that just came out yesterday, I think. I'm going to search a template. So I just start typing in template, and this comes up. And these are pre-made Polypad templates that you might find helpful to use with students. So there's some in the geometry section. I'm going to skip the geometry ones because we are here to talk about numbers. But here is a pre-made 1 through 100 chart, with the number cards. And so you could take all these and you can make them all the same color if you wanted to, and then have students go through and change colors of all the multiples of 3 or all the multiples of 5. One of the things on our to-do list is the ability for kids just to select multiples of 3 and then it happens. So that's not there yet, but here's a template of just the number cards for 1 through 100. Here's, can you take the numbers all off? Meaning like if you hide number labels, yeah, that doesn't turn the numbers off, but that would be a good feature, I guess, to be able to turn on and off those numbers. if you send me an email, david@mathagon.org, and let me know that suggestion, I think that would be a good feature. Yeah, you could certainly start with one at the bottom. Yeah, I just took this and I just made this, so you could have this number chart any way you want. If you think that would be a helpful template to have as well, shoot me an email. I will make it and add it to the template page. I've seen teachers use that as well. Here's a template of some number lines, some pre-made number lines. Here is the Cuisinart rods with a 1 to 100 tray, which I know is a popular activity. Here is the actual multiplication chart with the arrays of the numbers, right? So this is 7 times 7 and 5 times 6. Here's a fraction wall and all the fraction circles. And again, this is I'm going really fast here, but this is at Mathagon.org Tasks. And if you search for templates, these are all the links to the Polypad. I had clicked on the links in advance of the webinar, so they were in my tabs, but they're all right here. And what's nice about these templates, if this, say you wanted to use all the fraction circles under library, this is in my account. So, but on yours, if you open this, it would say save a copy. And then you have this as a Polypad in your account. If you just wanted to copy those, you can copy paste in between canvases. So unlike before where I just clicked C to copy it within a canvas, if I want to copy it and paste it, I do need to do Command C. So I'm doing Command C, and then I can go to a Polypad that I was working on before and paste it, and there it is. So I can get that out of the way down there. So that was the idea of these templates, that if I wanted to make all these fraction circles, it doesn't take that long, but to drag them all out and then do all the rotations, so those templates are there. So this was, a fast overview of the number tiles, a nice visual of all the things that we had just talked about, and I showed you the templates. Yeah, great. Glad those templates are helpful. Kelly, great idea about kids determining the hidden numbers. So that feature of being able to deselect some, I think would be great. So please send me an email. I'll put it in the chat. Our list of features that we want to add based on teacher suggestions is a growing list, and we are adding things faster than we are crossing them off. Mathagon, as you may know, I should have emphasized at the beginning, is free for teachers and students, will continue to be free. It's a pretty small team of people behind the scenes. Philip Legner is the founder and CEO. There's a couple of coders with him. I'm the head of content. Again, I'm a full-time teacher. We have a few other content writers that are full-time teachers as well, or do other things in the math field. So we're trying to get through our to-do list as fast as we can. So just some, ideas to share. So now, I don't need to save these changes. I was thinking just like a nice way for students to play with this could be just a task like show all the ways you can to represent the number 24, right? And so, one new feature, if you've played with Polypad before, I just made a text box. Bold, italicize, and underline was new as of a couple days ago. So I'll make this bold just because we can, because it's new, and underline it. All right. And then I'm going to go to the number tiles, and you could just have kids go and explore, and they can make any pictures they want for the number 24. So they could take number tiles, even them thinking about how do I want to build 24, I think is good for students. I'm going to do 20 and 4 and then merge them. And so I could show this. I could show 24's lots of ways here. There's 1 by 24. I could copy it and make the 2 by 12. I'm not going to do this whole thing because I've done it before, but there's 3 by 8. So they could make 24 that way. They could say maybe it's an 8 and a 5. They could match it up here so they know they're getting the right number. I'll do a 4. I'm not sure what I have left here. Maybe another 8. Is that going to do it for me? Right? Oh, that was too many. 7. Right, so I could do this and make the number 24 that way. Yeah, playing, chat. I know I've seen some of your great tweets out there, chat, about playing on Polypad. So there's 24 in a number bars. We certainly could do it in the prime factor circles. They could do it with number cards. We'll do 7 and 8 is 7, 8, 9. There's 24. And a feature that I find is really helpful for these types of activities is the balance scale. So I'm going to add the balance scale. That's under algebra. I know we're only talking numbers tonight, but certainly there's some good connections there. So I'm going to put the balance scale on the canvas, and kids could check to make sure they're all 24, right? They could take the prime factor circle and put it on there. They could take the 8 by 3 array, and it balances because the scale understands those are both 24. I could take this off, and I could put, oops, the 7, 8, and 9 on there. That's going to balance. I could merge those together if I want to show it's 24. We could put the number bars on the scale. That's all going to balance out, right? So this scale can be a really powerful way for students to check any sense of equality that they have to check. So that's pretty cool. I think a way to like build a number. All right, I'm gonna do a decimal multiplication example, which I think can be a nice use of the number line and the multiplication grid. I've taught decimal multiplication for years of like make an estimate, and so they see the idea of counting decimal places. I used the tool that I'm about to show you this year, and I found it a really nice visual for kids to have for decimal multiplication. So I'm gonna go to the task page. If you want to get this link at some point later on, you can. I'm just gonna search decimal. And here's this whole task on decimal multiplication. So there's a video of me kind of talking about what I'm about to do here, but it's this canvas that I want to have access to. So I'm going to pull up this canvas. And this is a pre-made decimal multiplication canvas that I've made. Now, these are question boxes that I made with the question builder. I'm in my Mathagon account now that I made this canvas on, so it's showing the answers. When I would share this with a student, I don't want the answers to be shown. So just to show how that works, I'm going to copy this and open it in a incognito browser tab. So here I'm going to the same canvas just where I'm not logged in. And so here is the multiplication grid that I got in the multiplication grid. I used the number line tools to make these number lines. And in middle school, when I was doing this as decimal multiplication, you know, they certainly knew that this 10 by 10 group, here's a hole down here. So they knew this was 100. They had great elementary teachers that had done good area model of multiplication with them. So they knew these were 10, and many of them jumped to this was 30, and this is 70. And they didn't really need to count these up. They saw that it was 7 by 3, and so they saw that it was 21 ones. And then I wrote down over here, they did that there's 300, and then the 30, oh, that's messy, I'm sorry, and there's the 21. And that adds up to 351. And when I type that into a question box, this question blank, I get a check mark because I got it right. All right, but now let's think about 2 times 7 times 13. So I'm going to erase this. It's going to get rid of the multiplication grid. That's okay. I can pull that up really quickly. And I think the ability to change the number line, the scale of the number line really quickly is a wonderful tool here. So there's 27 by 13. Oh, I'm off one. There we go. There's 27 and 13. So I'm going to click on this number line, and I'm going to change the top number line from a step size of 2 to 0.2. So now you can see I've modeled 2.7 times 13. And I like that students saw the actual diagram didn't change. It's just what we're counting by changed. But this green thing is no longer a hole. So we had good conversations about what size bar is a hole here. And they saw that it was 1 times 1. And so I took this, and this I made on it. Was no geometry webinar, but I'll show you. I made this with the custom polygon tool. So you can take this and you can drag it to make it bigger, and it snaps to a grid. So now by changing the scale, the size of our hole got 10 times bigger, right? So now we went through and we said, oh, this is 10. Those are 10s. These are all 1s, right? Because that's a hole. Here's 3, here's 7. And then good conversation about what this is. This was this hole split up into 10 pieces. So that was a 10th. And then they went through and actually counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, one hole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 holes plus a 10th. That looks like 11 and a 10th, but you get what I was doing there. So what we saw was it was 30, 10, 10, 7, 3, 3, and then 2 and 1/10. And just writing this on the screen was a great connection of how we changed the multiplication question. So this is what, I keep doing my dots there, 35.1, right? Oh, not 20. Oh, if I do 25.1, I get a red X, right? Because that wasn't right. 35.1, there we go. And then I'm just gonna do one more. I have so much more to share where it's not enough time. But now if I take the eraser tool and get rid of all this, this was a cool moment for kids. I'll put the multiplication grid back under numbers. Let's try to do it right this time. 2.7. I'm sorry, your screen froze. This is is being recorded, right? So you can always go back and watch this. But now I could do 2.7. I'm going to change this to a step size of 0.2, right? And now we had great conversations about what's the whole now, right? So now the whole, oh gosh, sorry. Now the whole is this, right? So they saw it's 1 times 1. And we went through and did the whole thing, 1, 1, a tenth, a tenth, a tenth. And these were 100th and had great, again, I took this thing that I have here and I did it again for this as a whole. And then I wasn't planning on in class making the whole here, right? But I took the number line and I changed it to a step size of 0.02 and made this 0.02. And of course, despite, I mean, I should have predicted this. It was great. They wanted to see the size of the whole, right? So I zoomed out. I'm not going to do it, but I made the whole. And actually what was great, even though I wasn't planning on doing that, they saw that this product is going to be a lot smaller than one whole. And I took this and I made the huge whole. I guess I said I wasn't going to do it, but it was a great moment that I wasn't planning on doing. I've messed up somehow, but they saw a whole that was like this big. And then we just made a quick estimate of how much of the whole that was. And then we were off and running down in decimal multiplication. So that was really cool. And then we got going into decimal division. And I want to share with you how I use the tools to think about decimal division. So I'm going to do a new Polypad. And I wasn't going to do 2 examples, but we probably just have time for 1. So let me do 2.7 divided by 0.15. Because I'm zooming and I'm recording, there's a little bit of lag with my pen tool. It's normally a little bit smoother, but that's happening tonight. So I'm going to first put a number line up here, and I want my number line to go up to 3. So I have 1 through 3. I can make the number line a little bit bigger. So I'll do a width of 15. Oh, not 25, 15. Maybe I'll make it a little bit smaller. We'll do 10. There we go. And then I can create divisions in the number line. So I'm going to split each whole into 10. So there's my number line. And at this point in working with division, I built up the idea with students that what this is saying is how many of the denominator do we need to cover up the numerator. So that idea had been established with kids, that division is all about covering up. And so then I took the geometry tools and used a custom polygon to build 2.7. And they did this with me, and then they practiced a bunch on their own, 4, 5, 6, 7. So there's 2.7. And so I made this bar of 2.7, not perfect, but just enough to kind of show 2.7. And then in a different color, I built 0.15. And so I'll get the green one up a little bit just so I can see the number line. And so 0.15 was about there. And again, it just created a great initial conversation of like, what's an estimate of this? I'm going to click lock so I don't mess up the points. And so there, I just had them talk with the person next to them, 3 feet apart with their masks on. How many of those do they think it'll take to cover up the green bar? And they went through and made an estimate. And then I can copy this. So I messed up with the vertices a little bit, but I'm going to take this. I'm going to copy a bunch. I could select like 4 of them at once and copy it. So there's 8, and let me do a whole set of 8, 6, 7, 8. So there's 16 of them, right? And so kids began to see how this compared to their estimate. That was 60, that's 19. Really rough estimate, right? I was not very precise in my measuring or the shapes, but it just tells us that our answer should be about 19-ish. Which is great, right? And then we talked about how, I'm going to move these out of the way so we can see the numbers, how like doing this division can be messy, but if we take this number line and instead of doing a step size of 1, we do a step size of 10, the picture didn't change. Now it's saying how many 1.5s, right? This is now 1.5 about, how many 1.5s go into 27. And so we talked about how this is the same as how many 1.5s go into 27. And we actually did that and counted up by 1.5. But then I took the number line and I changed it again. And we changed this to a step size of 100, right? And show that this is now the same as 270 divided by 15. And I think the ability to really quickly change the scale of the number line and see that the bars aren't changing shows that equivalency of what we're doing when we want to make the divisor into a whole number, right? The reason why we're doing that is to make the long division algorithm a little bit easier. But this picture shows them that's going to be true. And then we went out and did the long division. There has been a request. I think actually the person that made the request is on the webinar to have arrows here at the end of the number line. So I just saw that in the chat, and that will be coming soon-ish. You could add a math latex block tool like Desmos did, no pressure. There's an equation tool. I don't know if this is what you're talking about. There is the ability to do fractions and exponents, but there'll be more math type coming soon. So that's not there yet, but it's coming, as well as the arrows. So there's just a decimal division example. I want to show you some fraction divisions examples. I was going to do fraction addition tonight, but just being mindful of time, I'm going to skip that. I don't need to save this here. And I'm going to show you that there's a video on fraction addition, that if you just do a search here of fraction and go to fraction addition, I did kind of a similar idea of what I just did with the decimal division of changing the divisions of the number line, right? So I took the bars, made an estimate, and then added divisions of the number line until we got to a common denominator. And that was a nice visual for students. But since we're talking about division, I've always struggled to have my kids get a good visual of fraction division. So I just want to share some things that I did to be helpful here. So here's a canvas. Again, this is in tasks if you just search fraction division. This was actually an assignment that I gave to students. I'll talk in a few minutes about why these don't have the fraction bars. But if I zoom in on the first one, again, I'm in my teacher account, so it shows the answer here. The students, I'll actually do it. I'll go to a incognito browser so we don't see the answers, just to get the full student experience. And I'll zoom in here to the first one. And so again, as I said, this is after I built up the idea of covering up with division. And so at this point, they knew that this question was really saying, how many 1/6 do we need to cover up 6/9? So they took this and they actually made the fractions. I just gave them the wholes, and then they took this and they could copy it and copy it and copy it and see that it takes 4, right? How easy of a division was that, right? How many 1/6 do we need to cover up 6/9? 4, done, right? I think that's great. I'm going to do one over here. 2/8 divided by 3/4. So they were off and running. I think I did one example with them, and then they were off and running. And they got here and they were like, oh, 2/8 divided by 3/4, right? Many students initially, wonder if you can guess in the chat what they first wrote as their answer. They saw this and they put it on top. Any quick guesses as to what students first wrote incorrectly as their answer? Yeah, totally, Stephanie, 1/4, right? Because they saw the 1/4 covering up the 1/8. And so what I did to help there, I turned off the number labels, right, instead of 1/3. And as soon as I turned off the number labels and I just said, what fraction of the red do we need to cover it up? And I split it here and I said, oh, I just need 1 out of the 3 pieces, right? They were like, oh, of course, it's 1/3, right? So that was a nice, the ability to turn on and off the number labels made them a lot more successful on this task. And then, I gave this as an assignment in class. I was really interested here in seeing which students went to the fraction tiles and put these on the screen, right? Like, did students take the 1/2 and divide it by 1/5 and actually do it? Or were students able to visualize 1/5 going into a half, right? And that was great feedback for me as a teacher. There's a video out there I can show at the end how students can save their work and share it with you in Mathagon in Google Classroom. And then I could go and see which students, like on number 8, right? There were many students that could visualize this on number 8. Great, right? That's the goal in some degrees, use the visuals to then abstract them, right? But the tools are here if they need to use them. I've talked in other webinars, so I'm sorry if you're hearing me say this again, but one thing I find so helpful for kids on Polypad in general is giving them the ability to use the manipulatives when they want to, right? So they're always there on Polypad. I found in school, maybe it's more of a middle school thing, that we do a day of the manipulatives, they get it, it works, and then I put them on the shelf. And I say, of course, anytime you want to use them, go get them. They're there. It doesn't matter. Tests, quizzes, homework, classwork, go get them. But kids are a little self-conscious if they're going to get the algebra chips when they're adding integers, right? But here, when they're doing it on their Canvas, there's also something like kind of fun about like doing it, right? Yeah, Stephanie, this is easier than the rectangle model. I agree, right? So doing this can be really powerful for kids. So there's fraction division. A few last things to share, and then I'm gonna stop around 7:45 and just do any questions that you have. Let me show you integer subtraction. All right, so I'm gonna not do integer addition. There's a task here that I'll show you, but not do a full overview of integer addition, where you can use the 1 and the -1 of the algebra tiles. So just as an example here, these are like the number tiles, but they're +1s and -1s. And so what's nice about these on the integer tiles, these work like other algebra tiles out there. If you take 3 of the -1s and put it on top of the +1s, it makes a 0 pair. And so this is a Canvas where there's a bunch of questions for students to answer. Again, it's that same idea that I was just talking about. The manipulatives are there if they want to use them, right? So 12 plus -15. I actually saw students who I knew they could do that in their head, but they just had a good time taking the -15 and bringing it over, and taking the 12 and bringing it over. There's 10, right? And they just enjoyed the satisfaction of having the zeros. I keep missing, right? Of doing that. And even just the fact that this was inviting them to do it is building those connections, right? Even if they don't need to do it, it's fun to do. That's great. That's great for their brain. All right, but let me talk about integer subtraction, because that can be tricky for students. So I'm just going to do a new Polypad. I don't need to save these changes. And let me put a balance scale here. And I'm going to think about the question 5 minus -2, right? And if you've taught integer subtraction with algebra tiles, you get the idea of the 0 pair thing. But what I want to show is how I think the scale here can be really helpful. So here's 5, right? And so I'm putting 5 here. But then on the other side of the scale, I'm going to balance it with a number card, right? And so that's balanced, right? And then we want to take away -2. And so, what students might first just be tempted to do is go to the algebra tiles and put on -2. If there isn't something that you want in life, just do it. I've heard James Tanton say that a lot, right? But when I did that, I lost equality, right? And so that didn't keep it balanced anymore. And I want this to stay 5 before I take it away. I would have to do some talking with kids that I don't want to change this side yet. And they would have to understand that difference, right? But we'd get to the idea where if you add these 0 pairs, that keeps things balanced. This is still 5, right? When I take this and I move it off the scale, it's still 5, right? So by doing this, I've kept 5 here. If I wanted to model that in the number cards, I could do a 1 and a -1. Oh, I didn't type in the negative, and a -1. And there's a 0 pair in the cards, and I can put that on the canvas, right? And I'll just copy one of those. So it really is showing what's going on. And now I can say, oh, we can actually take -2 off each side. So now when we remove this, it's not balanced. We have to remove that to keep it balanced, right? And there's 7, right? So that idea of building the 0 pair and taking them away, I think the scale can do a nice job of showing that. This is the beginning of a task to come on Polypad at some point. I think kids would need to get the idea that you're building the number 5 in a way that you want, and then the action of subtraction is changing what you have on the scale. So that might need some scaffolding to get to that idea. I'm going to put in the chat a link to a site that has some links that aren't on the task page yet. If you go to mathagon.org/pd/ELEM, it just has some links to canvases that I'm going to share with you right now. Eventually, those will be on the task page. They're public. We've tweeted about them, so you can do anything that you want with them. So let me show you this. Actually was an idea from Chad, who was on the chat. And he had an activity with dice and the scale, and he let us know that the dice and the scale weren't quite working well. And that was because we hadn't explored the idea of putting the dice on the scale, and his students were doing it, and it told us there was a bug, and it got us thinking about all sorts of cool ideas with dice and scales. So this, I just took the dice and put them on the canvas. You can roll all the dice at once. And so this past week, it was vacation week in Massachusetts, and I have a second grader and a fifth grader, and I was trying to get them to do a little bit of math. And so I just made this quick task for them based on what I saw Chad doing. And the task I made was, can you roll the dice and put them on the scale so it's in 2 equal groups so the scale's balanced? I don't know if I can do this one. I'm not, as I said, oh, this might work out. Is that going to be a 6 and a 5? Did I do that right? I did, yeah. Amazing for almost 8 o'clock after a full day of teaching, right? It's balanced, right? Are there other ways to balance it, right? Are there some that don't work? Are there some that, are impossible to do? And so good conversations with my kids. And then I did it in my 7th grade classes and couldn't get them off it, right? They were having fun and contests. So so simple. It's fun to roll the dice. The scale works well. I just think these really simple tasks can be really powerful for kids. So that's there. Here's one, I think the ability for kids to think of numbers in lots of different ways. So this is just something I put with a whole bunch of scales, different representations of different numbers, and a task for students would be, add tiles, bars, or cards to balance the scale any way you want, right? So this is 23. They could go to the numbers and type in 23 and put that on the scale, balanced, right? And students could save their work, and then you can share it with the class to, have kids share with each other how they chose to balance it, right? I'm not going to do more of those. I think you kind of get the idea. And the last one to share, I put out last night, I think, an open middle question where this was a fraction division one. So this doesn't solve it for kids. I've seen some great Desmos open middles where it actually does the calculations for them, which I think at sometimes can be powerful. At times we might want kids to do the calculation themselves. But I think the example I did was 5/2 and 4/6 equals something. But you can take these, and then students can show their division with the fraction bars, both just to see if it's going to be a correct solution or see if it's going to be an incorrect solution. Equals, yeah, cool, awesome. So that's a good task. I have all sorts of GCF, LCM stuff to share. I do just want to give another plug for the task page, in that under library, it's always here under activities. We have about 75 or 80 things in this task page now. We have all sorts of lesson plans. There are some that are like a student exploration that you could actually assign to a student and have them do it on the website. It has embedded polypads in the task. So this first one says, can you arrange the 4 pieces so they fit inside the triangle? So you can actually do it right in the task. That's a student exploration task. Then there's a whole category called of lesson plans, which are fully developed like lesson plans. It'll flow like a lesson plan with, embedded polypads and links to them. And then there's a bunch of puzzles and games. A lot of these involve numbers that I didn't have time to talk about tonight. I just saw someone put in the chat one about Don't Break the Bank. This one, Blockout, is a great game for numbers. This is both from Dan Finkel and UCubed has a version of this. I'm going to pull it up because I think it's a great activity on numbers. And then I will take questions. But this, you've probably seen a paper version of this. You take the dice and you roll it. And you take that, and of course I got a 1x3. This is a 1x3 rectangle. So I'll put it on the canvas, but you can rotate it, you can spin it, whatever you want to do. And then, the next person would go if it's a 2-player game and they got a 1x2. So we'll take this and copy it. And then you can take it though and make it a 1x2. And then that player, could change the color. So they could be orange or something. So that's there. Under Don't Break the Bank. I don't need to save this. But then there's this category of things that we've called teaching ideas, which has a link to a canvas and a video of someone sort of talking about a way to approach that idea in Polypad. So if you go to do these and do teaching ideas. I think it's coming, teaching ideas. Yeah, there we go. So, we've talked a bunch tonight about the balance scale. Here's a video of me just giving an overview of the balance scale. It doesn't have any links to any tasks, but that one on fraction addition that I was talking about has a video of me doing an example and then a link to that canvas that I used in the video.